Hi everyone, let's try to do this trigonometry problem. So this here is trigonometry and we're just going to find sine and cosine of this angle that's given. It's not really that clear that it says all that with all this directions given. For the following exercises, find the reference angle, the quadrant of the terminal side, and the sine and cosine of each angle. By the way, this is Openstax, which is open to the public, free to the public to look at. You go to openstax.org, and this is Algebra and Trigonometry. I'll just call it Trig. And I think this is the second edition. Yeah. So that's free. You can just go to the book. You can learn trigonometry and algebra. Here we're doing the trigonometry part, and it's on the on the World Wide Web. You can go check it out and read about it, and lots of resources there. So this is a free to the public book. I mean, it costs someone some money, but for us, we get to look at this free. It's open source, so I'm not making any money off this. So I'm going along with the open source plan and answering this question, how to solve this. Maybe someone will use this. Okay, here's what I'm going to do. I'm using a right triangle approach. So here's my solution. I'm using a right triangle approach, and what I need to do is I need to determine where this angle is. What did I say? I'm using a right triangle? I'm using a unit circle approach, I guess. Maybe a little right triangle. But I need to find out where this angle sits on the unit circle. Now keep in mind that what we're doing here is we're looking at the initial side of that angle starting at the origin, and then we're going counterclockwise. Okay, halfway around the circle is pi radians. In degrees, that's 180 degrees, but I'm doing radians here because this is 7.6 pi. And by the way, I could edit this. Maybe it would look better if I put this, if I wrote it like this. It seems like maybe I'm on the track of not getting this done very quickly if I keep dilly-dallying doing things like this. But maybe it looks better to write like that. Okay, either way. So this is 7.6 pi. Halfway around is 180 degrees. That corresponds to pi. Now, what I do is I look at this and I write this as 6.6. Why 6.6? Because 6.6 is the same as 1. And what I'm trying to do is I'm trying to, I'm trying to refer to the x-axis, not the y-axis. It's always to the x-axis. Over here, this is 2 pi or 0, but 2 pi can be expressed as 12.6. And then I compare, I think, okay, I'm trying to find this little thing that, oh yeah, here we go. This little pointer. Okay, I'm trying to compare 7.6 to either 12.6 or 6.6. We don't do the y-axis, we do the x-axis. And this gets to this idea of reference angle. Okay, the difference between 7/6 and 6/6 is 1/6. And so 7.6 is 1/6 more. It's true we have to sort of know what a 6 looks like. A 6 is, pi/6 is, well, if I had pi/6 over here, that's where it is. See, halfway up is pi/4. Could do that, or is that making the picture messy? Sort of making it messy, but pi/6 is about that big. Out of those, we have these special angles. We have 0, pi/6, pi/4, pi/3, 0, pi/6, pi/4, pi/3, pi/2. Pi/6 is the small one. So you get this over here. And so the reference angle is the angle between the terminal side of 7.6 pi and the x-axis. That's the reference angle. I call this theta r, the r being reference. I don't think this Openstax book does this. Some other book from years ago did that, and I'm following along with that other book. But okay, I hope it doesn't confuse things. Now, so let's look at the quadrants. Quadrant 1, Quadrant 2, Quadrant 3, Quadrant 4. Well, now, one of the things we care about is that in Quadrant 3, the x-coordinate is negative and the y-coordinate is negative. Why is that important? Because on the unit circle, cosine is equal to the x-coordinate and sine is equal to the y-coordinate. So because of that, cosine is the x-coordinate, so cosine must be negative. Sine is the y-coordinate, so sine must be negative. Now, there are different ways to do this. So it sort of depends how you learn this or whatever your liking is. The unit circle approach, some people would say, is this, is that I look at this angle and where it's sitting, and I see that along x, I didn't want to do that really, along x, I'm going farther than along y. So the x coordinate must be larger than the y coordinate in magnitude. And we have special numbers that we have memorized, supposedly. And those numbers are the square root of 3 over 2 and 1/2. But how did I know that rad 3 over 2, square root of 3 over 2, comes first? Because along this length, I have more than along the y length. Moreover, they're both negative. That is one approach. There's also a right triangle approach where I draw a right triangle corresponding to pi over 6. Now, I will write over here pi over 6 is in radians, and that corresponds to 30 degrees. It's really a question how far back I'm going to go. Should I explain that? Well, maybe. If up here on the top is 90 degrees, 1/3 of that is 30 degrees. If up here on the top is pi over 2, 1/3 of pi over 2, 1/3 times pi over 2 is pi over 6. So they're the same. And then that comes to, did that pretty quickly. There's a whole lesson on that. Here's 90. 1/3 of it's over here. 2/3 over here. I can even put that. So you can divide it 30, 60, 90, divide in 3 pieces. Pi over 2 can be also split into 3 pieces. The fractions are a little difficult. Well, it's not that bad, but 1/3 times 1/2 is 1/6. They're the same. So down here, 30 degrees. In this triangle, we're also going to try to memorize. Here, I'm going to make the hypotenuse 2. The side that's the shorter of the legs of that right triangle is 1. You know, it looks smaller. The other one is rad 3. That's a bit of memorization. And then what we do is we say, well, cosine theta, and this, by the way, is just theta reference. Pi over 6, the reference angle. Well, I'll leave that reference off. The cosine of 30 degrees, which is pi over 6, is adjacent over hypotenuse. Sine of 30 degrees, opposite over hypotenuse. Adjacent over hypotenuse for cosine, opposite over hypotenuse for sine. Maybe it's better if I put those first, because the sine first, I mean, because sine, in a little rhyme, so ka toa, they could go sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. Then it goes toa, tangent is opposite over adjacent, though. But all right, so we have those. So the thing is that we have to adjust for quadrant 3. So therefore, sine, I don't know which, SOHCAHTOA has sine coming first, but when we do this unit circle approach, x is cosine, y is sine. And so in that case, cosine comes first. So what are you going to do? But anyway, sine of pi over 6 is negative in quadrant 3. Cosine pi over 6 is negative in quadrant 3 also. But these are the same. You don't have to do both methods. This first coordinate is cosine pi, 7, 6 pi. I guess I made a mistake. Sorry, everybody. This is supposed to have a 7 there. Is it worth it to redo the video? Probably. But, oh man, that's the problem with videos. You make a little thing. Not supposed to make mistakes. Teacher's supposed to get it all right. Do you want to see another method? Maybe not. Let's do it though. Maybe you don't want to be confused. Let's check this out. How's this? This is not a unit circle approach. It's just a circle approach. Okay, so here's pi again. 7, 6 pi is down here. What you do is you draw a triangle. So this is not a unit circle approach. You draw your triangle here. You get that that's 30 degrees because 30 degrees, again, is the same thing as pi over 6. So 6, 6 plus 1, 6 makes 7, 6. So should I write 30 degrees or should I put in pi over 6? I don't know. But this time we draw a triangle and you write it 2 is the hypotenuse. Well, that's okay, except that's not a unit circle. The hypotenuse, if I'm using a unit circle, would be 1. But you just do it anyway. And then you go, it's going to the left by rad 3, and you go down by 1. And then again, it's a little bit cheating because that's not a length. It's a directed length, putting the negative. Down gives negative. But then you stay putting that cosine or sine first, cosine 7, 6 pi adjacent over hypotenuse. As we can see, that's negative rad 3 over 2 because you have. So the thing about why would I do that is by putting non-fractions here, what happens is that it's easier to do opposite over adjacent, I think, especially when you get to tangent. Well, that tangent was opposite over adjacent. So it's easier to do opposite over adjacent or opposite hypotenuse because you don't have fractions. So that's why I'm saying that we can do it that way. So, but that's not a unit circle approach, is it? But that's still a good one. And so another little fact here is that I said on the unit circle that on the unit circle, the x-coordinate's cosine and the y-coordinate's sine on the unit circle. But on this situation, we tweak that a little bit. Cosine theta is not just x, it's x divided by r, which corresponds to adjacent over hypotenuse. And sine theta is y over r, which gives opposite over hypotenuse. It's not that bad, except my writing is degenerated into messiness. And then tangent theta is still as the unit circle y over x, which is opposite over adjacent. So if you're using a non-unit circle, you can do that, but you don't. But the x-coordinate, if you are going to put down the coordinates here, negative rad 3, negative 1, it's what? Okay, I made a mistake there. So it's x divided by the radius is cosine, y divided by the radius is sine. But you don't have to do that. You just look at this little circle here. Oh my gosh, that was so many ways of explaining something. So it makes it seem really long because I explained this in several ways. I did the unit circle approach, and the unit circle approach you can do very quickly. You find where this is, and you get these coordinates. You get the x coordinate, y coordinate, bit of memorization, and x is cosine, y is sine. The right triangle approach, you draw a 30, 60, 90 triangle. Opposite over hypotenuse is sine, opposite adjacent over hypotenuse is cosine, and then you adjust for the quadrants. Quadrant 3, cosine sine is negative. Another approach is sort of a modified circle and triangle where you draw your little 30, 60, 90 triangle and you put the negatives in for the direction and then get adjacent over hypotenuse cosine, opposite of hypotenuse sine. Okay, well, you can take that for whatever you think it's worth. And that's section 7.3, number 43 from Openstax Algebra and Trigonometry, second edition. Okay, goodbye.